Another application in trigonometry is involve the angle by an observer. The angle observed by an observer will be classified as two different ways. One is called angles of irradiation, one is the angle of dispersion. First, when a man observes an object about him, that means the point is higher than the man. The angle between the line of sight and the horizontal is called the angle of elevation as the figure. It is the line of the sight and it is the horizontal. The angle between these two lines is called the angle of elevation because the observer wants to look upward. So in the figure, we say the angle of elevation of Q from P. P is the observer, is theta. On the other way, when a man observes an object below him, the angle between the line of sight and the horizontal is called the angle of dispersion. In the figure, the man is looking downward to look at the point Q. P is the observer, and the horizontal line and the PQ will have an angle called phi. In the figure, the angle of depression from Q from P is phi. In the figure, we see that theta is the angle of elevation of A from B, and the angle phi here is the angle of depression of B from Q. How are the theta and phi related? Give the reasons. You see there are two horizontal lines. That means they are parallel. And here it is an E-shaped shape, which means these two are the alternate angles. So we can say theta is equal to phi, since they are a pair of alternate angles formed by the two parallel horizontal lines and a transverse. So we have a conclusion. The magnitude, that means the values of the angle of elevation of a point A from B, here B is the observer, is the same as the magnitude of the angle of depression of B from A. Now A is the observer. The two observer is turned around, and the angle of elevation and the angle must be equal. By measuring the angles of the elevation and depression and using a suitable trigonometric ratios, that means you may use sine, cosine, and tangents of a certain angle. We can find some distance and height which are difficult to assess. Let's do some example. Here you see that there are points P, Q, and R. When you're looking at the question, you must know that which point is your observer. In this example, in the figure, you want to find the angles of depression of P from Q. So Q is the observer. That means this is the observer here, and this is looking downward. So this one is the angle of depression. So there's no mathematics step. You just write down the angle of depression is 30 degrees in this part. But for the second part, the angle of elevation of Q from R. Here from R, that means R is the observer. Now the observer observes the point Q by looking upward. So this is the angles of elevation. But you want to measure the angle is the line of sight with the horizontal. So you may sum up these two angles. So part A, you direct write down the angle of depression of P from Q is 30 degrees. For part B, you want to find the angle of aeration of Q from R is equal to 15 degree plus 60 degree, which is equal to 75 degree. The next example here, you will find this is a diagram. In the figure, there's an airplane. It's flying near the PB of Timosan, which is 958 meter height. If A is 2,500 meter above the sea level and AB is 5,000 meter, find the angle of aeration of A from the PB correct to the least 0.1 degree. In Form 3, if you want to find some angle in trigonometry, you must first find out the right angle triangle. But in this diagram, you cannot find it exactly, so you may try to find a figure which contains right angle triangle. From here, A and B are above the sea level, so we can observe the sea level just like here. Then you will have a trapezium, just like the following. So we draw the sea level with a point line CD, and the A and B are 2,500 meter and 985 meter above the sea level respectively. So you can draw a trapezium like that. In this trapezium, these two lines are vertical, so they are make right angle here. And you can divide your trapezium into a right angle triangle and a rectangle. So according to the trigo ratio, you can consider the triangle AEB. So in the triangle AEB, we must first find out opposite to the angle theta is the length of AE. So this length is calculated just by using 2,500 minus 958. It is the opposition side. And here AB is the longer side because it is just opposite to the right angle. So it is the hypotenuse. If you have the opposition side and the hypotenuse, then the sine theta can come out by the trigonometric ratio. For definition, that is the AE divided by the AB. And the AE is just equal to 2,500 minus 958. And the AB is 5,000. So you can calculate it is approximately is equal to 0.03084. By pressing your calculator, theta is approximately 80.0 degree, correct to the 0.1 degree. You must show that you cannot write 18 degree because you want to have one decimal place, so you must see here it has a 0.0. So at the end, you must have the conclusion the angle of aeration of A from the PB is 80 degree, 80.0 degrees, sorry. Now let's look at a question. Sometimes someone will observe the star. You'll observe a shining star through the top. That means the top of a windows here. At the time, he is at a position 0.8 away from the window. If you say 0.8 meter away, means that this one is a horizontal distance only. And P is 2 meter above the ground, so you know that the top of the window is 2 meter above. If you construct, this one is also have a trapezium here with the two vertical line here. So you can draw the diagram with a right angle triangle as shown. First, find out this right angle triangle and then draw it and mark the angle you want to find. This angle is the angle of aeration, theta. So you may say let theta be the angle of aeration. Then by looking at this one, you find that you have the horizontal line. It is 0.8, which is equal to the distance between neon and the window. 0.8, sorry. And it is the adjacent side of the with respect to the theta. But the opposition side of this right angle triangle with respect to this theta is the length of P window here. So this distance is just equal to 2 meter minus 0.6 meter. So you have the opposition side divided by the adjacent side. Opposite divided adjacent is equal to the tangent theta. By calculate, this is equal to 1.5. Then press your calculator, you will get theta is equal to 60.3 degree. Correct to 3 significance. So when you do your problem, you always want to find some geometry. The shape of the geometry may be a right angled triangle. But this right angle triangle must be on some figure. Just like here, you have a trapezium first. So at the end, we have the conclusion, the angle of aeration is 60.3 degree. Let's look at one more questions. A bird is trapped on the roof 9 meter high. That means some bird is here. And the firefighters are trying to rescue it. The top T of the ladder, here is the top T at the same level as the bird. Suppose the foot S is here, of the ladder is 2 meter above the ground. So that means this is 2 meter here. And the length of the ladder is 15 meter. Find the angle of depression of the foot S from the top of T. So that means you want to find the angle is this one. But this one you will find you can draw a triangle, a right angled triangle and a rectangle to form a trapezium. This angle is the angle of aeration of the point T from S. You know that this angle is the same as this angle. So that means I can draw a right angle triangle here to find out them. So we will say that let theta be the angle of depression and then draw the right angle triangle. Sometimes you may draw here to find out this one, but this one is the same as this one, so you can draw the triangle here. In here, you are not cutting your trapezium into two parts. You fuse a right angle triangle to make a rectangle for the whole picture. Here, you get a right angled triangle. Then you know that this is the right angle here. 15 meter is the longest side because it's opposite to the right angle. So it is the hypotenuse. Now the theta, opposite to the theta is the length of this. This one is the opposition side. This length can be calculated by the length of 9 meter minus the 2 meter. So you can find out this one. The opposition side and the hypotenuse of the right angle here. So this one must be using sine theta. So the numerator is the opposition side minus 2. And 15 is the hypotenuse 15. So sine theta is 7 over 15. After you write down this one, you press your calculator, shift sine and 7 over 15, you can calculate the theta, which is a 28 degree, correct to 2 decimal place, and make the conclusion. We have the angle of aeration is 28 degree. So according to the previous two questions, we always find a trapezium. Sometimes we cut the trapezium in two parts, one right angle triangle and one rectangle. The other is you fill a right angle triangle into a trapezium to form a rectangle. The other kind of question is if you are given the angle of aeration or the angle of depression to find the height of certain object. Let's look at this example. In example 4, the Central Plaza in Hong Kong is know that the elevation of a point A of the building from a point B is 1 meter away is 75 degrees. That means the angle of elevation from the observer B to the top of the point or the building, you have 75 degrees. You will want to find the height of the building. Here, correct to the nearest 10 meter. But sometimes you want to find a certain point of on the building and make the angle of depression of the point B. That means the previous observer from some certain point like the point D. And we know that the angle is just a half of the original one. Is this the point D is lying on the midpoint of AC? So we must want to calculate what is the height of the point above the ground. In order to build up this kind of problem, we must first consider the building like this. A is the highest point, B is the observer. You can observe the point A from the B with the angle of 75 degrees, and B is 100 meters away from the building, so the horizontal distance here is 100 meter. Because we always assume that the building is a standard right angle with the ground, so we must have a right angle here. So after we draw the right angle, then this one will form a right angled triangle. And the required distance, the height of the building is to find the length of this AC. And the length of AC is just the opposition side of the angle of elevation. But the length of BC is just the adjacent side. So according to the opposition side divided the adjacent side, it is equal to the tangent angle. So we say in this triangle, we can calculate AC divided by the horizontal distance 100 meter is equal to tangent for the 75 degree. So arrange, we get AC is 100 tangent 75 degree. By pressing your calculator, you'll get 340 meter. Now at that part, we want to find another point D, maybe something here. Okay, let this point is D. Then after you draw the D, then this one will observe the point B with an angle of depression here. So we will draw a point D and make a horizontal line and then connect the point D and B to form the diagram. Just like this one. So the angle of the depressions, because it is different from the this one, so we use another letter, angle phi. Here angle phi is the angle of depressions, and this angle is just half of the angle of elevation of A from B. So we get it is equal to 37.5 degree. So in triangle, we can calculate this angle phi is just equal to this one. So according to this right angled triangle, we can calculate the DC. And DC is the opposition side of this angle. So DC over the adjacent side is still using the tangent ratio, which is the angle DBC, but we know that it is 37.5 degree. So arrange, we get DC is 100 tangent 37.5 degree meter. What is the answer? You may press your calculator. See, it is 80 meter. You want to determine whether D is the midpoint here. You originally know that AC have the length which is equal to 373.2 in part A, and we calculate this is just 190 if this is the midpoint. But now DC is just 80 meter, which is not equal to that. So that means I cannot say that the point D is the midpoint of the A. Let's try similar questions. In question 6 here, the angle of elevation of the top of two international financial centers from a point on the sea level is 153 meters away is 70 degrees. You want to find the height of the building, just like the example. You want to find the height first, and then you find a point X which is on the building, and see that the angle of elevation is just 1/5 of the original one. So is it X is at the level which is also 1/5 of the height of the building? So we must calculate this one. Now we construct a triangle, a right angle triangle like this. But your figure is just a picture, so how to do that? We must first draw a point, top of the point here, and then this point here, and then 70 degrees here, and then omit this diagram to build. The top is just the letter T, O is the foot of the building, and P is the observer. And the angle of elevation is 70 degrees, so you get this one. This one must be right angle because we assume the TO is perpendicular to the ground. So the TO is the required height, that means the height of the building we want to find. So after we get this one, this OT is the opposition side. So opposition side and also the OP is the adjacent side. You are given that it is 153 meters. Opposition side over the adjacent side, it is also using tangent. So tangent 70 degrees is equal to the TO over the 153 meters. Range, always do the same thing like that. Range you get the height of the building is 420 meters. So the next step is we want to draw a point X here, which is make a angle of elevation of here is just 1/5 of the original angle here. So we may have this one 70 degrees divided by 5, which is 14 degrees. According to this right angle triangle, I can calculate the LX is the opposition side of this angle, but this angle is the same as this one. So that means OX is the opposition side, 153 is the adjacent side. Using the opposition side over adjacent side is the tangent, we can calculate the OX, which is the 38.1 meters. Now the next step, we want to check whether this OX is just 1/5 of the building, height of building. So we find that it is not. So we say that the X is not at a level which is 1/5 the height of the building. These two example questions show you how to find a building, and then using the requirement to check some point within the building and check if they have a ratio of the angle. The height is also with the same ratio. They are not in these two questions. So the next one is about two buildings problems. Here the angles of depression of the top and the bottom of the HSBC, that is the famous band in Hong Kong, from the top of the adjacent band of China's are 29 degrees and 47 degrees. That means in the building of the HSBC headquarters, you have two angle of depressions. One is the top, and if the band of the China is 368 meters, find the height of the headquarters. So you will find the diagram will be like this. This is the China Tower building, and there are two angle of depressions. Observe the top of the HSBC headquarters and the roof and the foot of here. So we let this S is the top and S dash is the foot of the HSBC headquarters. Now, because every building must make a right angle with the ground, so we draw two right angle, and you find this is a rectangle here. If you want to find the distance of this, you must know the distance of this first. If you know this, want to know this distance, you must using this right angle triangle. But if you want to find this using this right angle triangle, you must get the length of CP. But you know that the CP is just the opposition side of this rectangle, so CP is just the length of this one. And this length you can using this right angle triangle to find out with a 47 degree here, which is an alternate angle, and find out this line. After you find this one, you find this one. This one is and then you can find out the PS. After get the PS, you're using the height of the Chinatown Tower minus this height. So we will get this triangle first. This triangle CPS dash, this right angle triangle. This is the opposition side PS dash, and this 47 degree, and this one CP is the adjacent side. So the opposite side over adjacent side, it is equal to the tangent 47 degree, and which is equal to 369 meter, because these two lines are equal. So I can calculate the CP is equal to 369 meter divided by tangent 47 degree. You may not want to calculate this value at that moment, because you are not want to find this length. So you can keep this value here. And after you get this one, then you will using this another right angle triangle. It is the adjacent side of the 29 degree, and PS is the opposite side. So this one is also a tangent ratio. So I can say tangent 29 degree is just equal to the opposition side PS divided by the CP. Now the CP we just calculate in the previous part, it is equal to 369 divided by tangent 47 degree. Now I write it down and then press just the calculator one times and get the answer by putting the total length of this one, which is equal to the CC dash, and then minus the PS. Okay, so we get 369 minus this expression. After we write down this one, you just press your calculator and then get the answer of the height. And this kind of problem, you will find that we always find some distance, which is maybe the difference of two lengths, or the sum of two lengths. So this is a kind of example. You want to find this length, you must know the total length first by the opposite side of right rectangle, and then minus this length. This length is calculated by this right angle triangle, but you must first know this side, so you consider the largest right angle triangle to find it out first. That's another question 7. Jimmy stands in front of his home and finds the angle of elevation of the top and the bottom of an advertising box outside a tall building are 70 degree and 50 degree respectively. Jimmy estimates the roads between his home and the building is 8 meters wide. What is the height of the advertising box? So this diagram is similar to the problem. You can fill up a rectangle here to get your similar pattern. If you want to find this one, you must first find out what is the length of the building. This one, the top of the building or the advertising board to the ground, and then minus the length of the bottom of the advertising board to the ground. So if you want to calculate this length of the top to the ground, you want to consider the largest right angle triangle, and then find out the length of this one. You using the smaller triangle, and then using these two result and one minus the other. So when we doing this one, we will draw a diagram like this with the rotation figures. First, I calculate the OB. OB is the opposition side of the 70 degree, and the JO is 8 meter, which is the adjacent side. So opposition side over adjacent side, it is the tangent. So you will get OB is equal to 8 tangent 70 degree meter. No need to calculate at that moment. And then consider the smaller right angle triangle. We still using the opposition side OA over the adjacent side JO, which is equal to the tangent 50 degree. So I get 8 tangent 50. So if you want to calculate this length, then you can just using the OB minus the OA. And then we will get the length by pressing the last expressions once by using calculator and find out it is 12.4 meter. This is the special calculation. You need not to calculate the intermediate values. If you calculate, you will not deduct any marks in your examination or test, okay? But in order to save time, we will press the calculator at the end. So we have the conclusion that the height of the advertising box is 12.4 meter. The other question is like this: you not have not two buildings but have two observers. Here you see that the status of liberty from the two saying vary. That is the two observer. So there's although it is a triangle, but this is not a right angle triangle. But this right angle triangle can be cut into two right angled triangle. So if I want to do the problem like this, I will cut it into two right angle triangle. And I can see that this length, the total length between them is just the two adjacent sides of the two right angle triangle added together. So this time you may want to try to find out the length by using one triangle, and then the other one will come out. You want to find the height. So in this problem we will let some unknown first, because the height of the building we do not know. So we will let the height of the building is called the AB. But if you always write down AB, is not easy. So we always let this one is called the H meter. After I draw this H meter and then construct the triangle as the figure, I have a right angle triangle on the left and right respectively. There are two triangles joined together side by side, okay, and they are different angle of aeration. This is 30 degrees, so we can calculate this length, and this triangle I can calculate this length. If I want to calculate this length, I can in terms the PB find the PB in terms of the H and the BQ in terms of H. So that means the PB and BQ are in terms of H, and then add them together, I get the answer, which is 221. This is an equation, and then solve it. So in the left hand side triangle, I know that H meter is the opposite side and PB is the adjacent side. So I have H meter over the PB is equal to the tangent 30 degree. So at that moment we will not want to calculate the exact value, so I keep the H still here. So I say PB is just equal to H over tangent 30 degree. Similarly, for the right hand side, the right angle triangle, using the same method, AB over BQ, which is the opposition side over the adjacent side, is equal to the tangent 40 degree. So I can find out BQ is equal to H over tangent 40 degree. If you find a similar problem in any exercise, you can write down every time the opposition side divided by the tangent angle will get your adjacent side. And these two are the two adjacent sides of the two triangles, APB and AQB. So they add up together is equal to 271. So I can add the PB and BQ together to form an equation which is equal to 271. On the left hand side, in the algebra, we know that H is a common factor, so you can take it out. which is leaving the remaining term inside the bracket is 1 over tangent 30 degree plus 1 over tangent 40 degree. Now divided the expression of this bracket to the right hand side, I can get the answer directly by press the calculator, and this is 93. After we get 93, we must take a conclusion that the height of the building or the Statue of Liberty is equal to 93 meter. Any problem about that? This is two right angle triangle joined together, but sometimes the two right angle triangle may not joined together. The smaller right angle triangle will be cut out of the largest right angle triangle. So in this case, you may use minus rather than using plus. This is the next example. Next question, sorry. The hot air balloon is observed from two positions P and Q fitting apart. The angle of variation. Find the height of here. Here you will get that this is a two right angle triangle, and the smaller right angle triangle cut out of the largest one. You are given the information about this length. So in this problem, you will find that this one you want to find the height of the balloon above the ground. So you want to let this length is equal to the h. So in here I can using the symbol OB divided by the OP PO, which is giving the tangent 49 degree. So the PO is just the OB divided by tangent 49 degree. Similarly, for the smaller right angular triangle, we get the OB over OQ, it is equal to tangent 65, so you get this one. In the previous example, we add the two lengths and then join it together to get the total length. But here, you are just giving the difference between the P and Q. So that means that you are not using addition, you are using minus. So we have the total length for PQ is the PO minus the OQ. Now, because the OB and OB are the common factor, so we take it out. In order to save the space, I just divide this one to the right hand side directly and then calculate the OB, which is 134 meter. You can include a step that is the 54 divided the expression here and then get the answer at the same time. So that these two questions show that you always find two right angle triangle. They may join it together, or they cut out one right angle triangle from the other. If you join it together, you're using addition. If you cut out one right angle triangle from the other, you're using subtraction. So the height of the balloon is 134 meter.